Good morning. So the talk today is going to be about IoT and how Apache MiNiFi and NiFi could help in IoT solutions. Probably not a surprise to anyone here that every business is pretty much becoming a data business. It's no longer that you're in agriculture, you're in data, or you're not in pharmacy, but you're in data. And everything's turning into a data business. When you look at some of these systems and you look at where all the data is starting to come from, and a lot of data, it ends up being in this IoT and more in industrial IoT. And you'll see things where there's different data sets coming from oil rigs, coming from cars, coming from sensors, lots of data from all different types of systems far out on the edge. This causes this disconnect where you've traditionally had this operational technology system that's out on the edge, collecting data, dealing with sensors, dealing with equipment that's in a farm, in a shipping plant, in a manufacturing setting, in a shipyard. And you have the IT systems that are on the other side, usually in a corporate office or where things are happening in an analytics center or a data center that's completely separate from this other world that's been out close to the edge. So you end up with this chasm that you have to try and bridge between the two. You have the world where there's all these sensors, that it's been very high volume of data, moving very fast. And then you have another world that we're used to working in where it's a little bit slower in many cases in different types of systems. And how do you bridge that gap between the two? So the challenge you end up with is something like this, where say you want to collect 20,000 time series pieces of data sampled at 1 hertz from different control systems. And you want to deliver this data in a format that could be used by data scientists. And you also have to deal, of course, with other things in the mix, like a satellite connection. You don't often have robust network connections as you look out at the edge where some of these systems are. So how do you deal with that and get this data back? If you look at a reference model from the IoT World Forum, you see this as a reference model of how to think about this world. At the very bottom, you have this physical devices and controllers, things that are out running on hardware, whether it's a crane in a shipping yard or on a train. And the connectivity to deal with. And there's edge computing. There's lots of environments where you need to actually do computing there, make decisions at the edge. They can't afford the time delay for data to come all the way back, make a decision and send it, or in some cases be able to move the volume of data from the edge all the way back. You have some sort of data accumulation, subtraction, in application reporting, collaboration. If you kind of lay this out between this operational technology stack and traditional information technology where we're trying to bridge this, they meet just about there. Right? So at the top, it's the things that we're used to in a lot of enterprises of having queries, having data at rest. In a lot of cases, it's still some real-time data, not the same as what you may see that's hard real-time on a piece of equipment, but nonetheless real-time of it's constantly moving, very low latency. And then below that, you can see where you have this very event-based, this data in motion, in some cases truly real-time, where you're reacting to sensors on a piece of equipment and having to make decisions. So if we laid it out this way, in a way we're used to looking at things, you could think about this collection of wherever it may be on the edge, whether it's planes, trains, automobiles, possibly go into some process center, that could be a regional data center that you have things, and then store and query perhaps in an analytics data center where you're going to get the data back, run some deeper analysis on it, provide query tools for people to access this data, data scientists to use the data, make decisions. So you can see we look at this being event time all the way to access time, somewhere along this continuum. So if you look at the problems you run into in these environments, there's at least 6 core themes that come up of what you need to solve problems in this world. One of them is prioritization. Not all data is equal. Right? So some data is going to be more important that you react to before other data. Right? An alarm going off on a piece of equipment that something as bad is about to happen has higher precedence over just logged events that are going through. Right? So you're going to want to prioritize the data. Connectivity. Oftentimes, you don't have great connectivity on the edge somewhere. Just think about how we have loss of connectivity with cell phones as you're walking around a city or in different places. It gets worse when you get somewhere where you're out in the field farming, or it's on a ship somewhere and you're trying to get data and trying to move data back and forth. Well, real time, in a lot of cases, this data is moving at high speed. You need to react to it on the edge or be able to have it go all the way back and make decisions in real time. Security becomes of paramount importance. You see a lot of environments, and you talk to people that work in that field, you talk to businesses in that field, where they'll tell you that, look, in our shipping yard, that is completely disconnected from the rest of the enterprise and actually has no access to the outside world and on completely separate networks. So things could be secured and not exposed to different things. So you deal with a lot of connectivity and a lot of security. Having data provenance, understanding what happens to a piece of data as it's moving, understanding the actions that are taking on it, and being able to understand what happened and where it went. And then extensibility. Right? You're going to want to look for a solution that you could extend and change as business needs change, as the environment grows, as the needs change, and there's new use cases. So I'll start to talk about Apache MiNiFi, and then we'll talk about MiNiFi, and go through how these two tools together could handle a lot of these use cases and do meet these 6 core features that you'd look for in an IoT solution. A simplistic view of data flow, which is a problem NiFi is designed to solve. Oftentimes people think about data flow and they have this picture in their mind. Right? I have some place that I'm going to acquire data, just goes through this nice smooth line, and then I'm going to store the data somewhere that could be queried. Reality is, this is what it looks like. Right? And I'm sure a lot of you have seen this in different environments you work, that it's not a simple straight line. Your world looks like this. You have data coming from all different places. You have different teams that are storing data in different places, processing data in different places, and you have this tangled mess of data movement. I think we end up in that case really kind of matches with this cartoon of how we end up in that world. Right? Where you start with, say, 14 competing standards for something. Of course, that can't be good, so you have to sit down and come up with some common standard for the entire thing, and then before you know it, you end up with 15. Ironically, as a side note, I had sat with a customer at one time, I had showed them this, and they started laughing, and I had asked about it, and they said that they literally had 14 content management systems. They decided to have a 15th one to just overrule all of them, and now they had 15 systems. So I think this is like the 7 degrees of freedom from Kevin Bacon. I think there's like some magic to this 14 systems that you have, and then you have a common standard in 15. And if you look across the protocols that we use, the data formats we use, it causes a mess, right? So Apache MiNiFi was designed to solve this problem. Started at the NSA a little over 10 years ago to solve a data movement, data flow problem, and is still very much in that direction as to the problems it's trying to solve. It's a web-based UI that we'll take a look at. You think about it being directed graphs of routing and data flow, data movement. Very configurable, extensible, and has data provenance to track the life cycle and the movement of data and what happens to data all the way through its journey. Some of the key features you'll see in NiFi: guaranteed delivery, data buffering, so you could have prioritization, you could have back pressure, flow-specific quality of service, data provenance, recovery, visual command and control, something that's a little bit different than a lot of other tools, where it's not design and deploy, but you're visually command and control something. You think about it like you're molding clay. It's pluggable security designed for extension. So we'll dig into a couple of these, and if you think about it at a high level, it really is this Swiss Army knife of data movement. So you could acquire data from a whole variety of sources, whether those traditional systems you're used to, being Flink, S3, Kafka, a sensor, whatever it may be, do some sort of processing of that data, make decisions on it, and then deliver it to another system. Again, that could be S3, Hadoop, relational data store, whatever it is you may want. Some terminology to kind of start to think through when you start to look at NiFi and also MiNiFi. The first is this notion of a processor. So we'll see in a moment in the UI that a processor is really just something that you use on the canvas that's designed for ingress of data, any sort of transformation of data, routing of data, or egress of data. So it's just a processor that's responsible for anything you do. You connect these processors in the graph with a connection. Think about this as a queue in between them. The data that moves between processors across this connection is called a flow file. The easiest way to think of that is you think about an HTTP response. It has a header, and then it has a content. A flow file has the header, which are attributes, and then the content which is a pointer to where that data lives on the system. Okay, so very similar to HTTP response, conceptually it's just this header and content. And then you have what's known as a process group that allows you to visually group processors together. And you could also have this notion of remote. And the idea is that it allows visual coupling of it, so you could have things cleaner, and then you could handle it a little bit smoother. If you want to wait to the end, that would be fantastic. Thank you. If you're familiar with flow-based programming or come across flow-based programming, Apache MiNiFi is based heavily on flow-based programming and the concepts of it, and has its roots tied to flow-based programming, and you'll still see these concepts permeate today. If you follow the mailing list, you'll often sometimes see discussions that come back to these core tenets of flow-based programming. It often isn't called out that this is because of flow-based programming, but having an understanding as to what flow-based programming is helps give insight into why NiFi does certain things the way it does, and some of those design decisions. So you can see a flow file's information packet, there's bounded buffers, and there's subnets and so forth. This is what the NiFi UI looks like. So you can see this generate flow file that we consider a processor. There's a relationship in between that and this route on attribute processor. That relationship and that connection right there is a success. That's a connection between them. And then there's another connection to this process data that's down below, which is a process group. Okay, so you'd have two processors there, this processor group, and two connections between. And we'll look in a moment about the buffering, but you could see that in that first relationship, in that success queue, there's 10,000 flow files that are queued, and they're occupying, in this case, 0 bytes. And then you can see the relationship below. So the need for data provenance. For operators, you really want to have traceability. You want to understand what happened to the data all the way through. You want to be able to recover and replay data. For compliance, oftentimes you need an audit trail. I've worked with customers that are in the finance sector where they want to understand every single thing done to a piece of data. They'll take the provenance data from NiFi, store it into an external system, and they could do historical reporting to understand everything that happened. Okay, so you have this trace of what happened to the data in an auditable fashion that you could use to prove what happened to the data as it was in flight. When you look at data provenance in NiFi, it's not just lineage. Right? When you think about lineage of data, you think about just the journey that it went on. That data went from A to B to C and it landed at D, right? Just the journey it took. When you think about provenance, it's about what happened to the data. What happened and who did it? And so not just the journey it took, but actual transformations of the data. So this shows you part of a UI from NiFi of looking at the data provenance. You can see here it's about putting data into Solar. I think you click on that tree and it pops up, shows you visually the lineage of the path that it took, but then also the provenance event. And you could see the data, what it looked like before it came into a processor and when it left a processor. So you can see input and output to a processor and understand what happened to it. All of this is being recorded. All of this could be sent from NiFi to another system as a stream of data that you could then load into an external system to do further processing on. The same people that, again, load this into a data system, sometimes HBase or other systems, to then do historical reporting and know exactly what happened. Other customers and other people use NiFi and use data provenance to build dashboards to understand what a flow is. So you have different options of what you could do, but very rich data that's being translated and being recorded every time something's happening to a piece of data. When you look at data provenance, and we'll see with Apache MiNiFi, that it's all the way from this origin. So all the way from the edge where you're collecting it, you can start to get data provenance of what happened to a piece of data all the way through when it comes back. Right? So it's not just lineage of this event occurred and it transferred from system A to B to C, but it's what happened to that data as it was moving. When you look at fine-grained security and compliance, this becomes very important as you're moving data, whether it's with NiFi, just in an enterprise setting, or it's NiFi and MiNiFi, and you have things distributed all the way out to an edge. You want to understand and have things secured. On the wire secured, at rest secured, as the data is in flight, and you want to control access to who can do what to this data, whether it's to see the data, to modify the flow, or perform any action. And again, the security is from front to back. So you may want source on the end where this data needs to be signed, needs to be encrypted, needs to be transferred that way, needs to be encrypted on the other end. You want to move this data all the way across securely. We look at data buffering and back pressure, and it's also a core tenet, right, of reactive programming, of being able to have back pressure and buffering so you don't tip over a consumer of data. NiFi has a very same principle of allowing there to be back pressure between NiFi instances and between processors. So now when you look at a processor that's producing data, and we saw that UI just a few moments ago of another processor that was receiving those flow files, you could apply back pressure, so therefore you don't overwhelm that consumer of data, and you allow that back pressure to build up, and then it can be released once the consumer starts to consume data. So if you look at it, this is a close-up of that UI we're looking at. We have this generate flow file, and then route on attribute. In between, there's a connection and shows that there's 10,000 flow files, which is what was configured on that connection to show that we want the back pressure to apply at 10,000 flow files. And you can see the other line underneath is size. So you could drive back pressure based on the number of objects or the size. In this case, that generate flow file is actually stopped, so it's not the best representation of this concept, but if that was still running, what NiFi would do was it would not schedule it to actually run and to actually have cycles, so therefore it wouldn't be producing more data until a route on attribute is either running or it could catch up and that back pressure goes below the threshold. This will work as you go all the way through the graph. So as you have processors that can't keep up, back pressure is reached, and that threshold gets breached, and NiFi will work its way back to stop scheduling processors in the graph from producing more data. And then as the back pressure is released, in this case it would be route on attribute running and that queue dropping below 10,000, then the other processors would be scheduled to run accordingly, and you'd have data that moves back and forth. Guaranteed data delivery. So even at very high scale, NiFi guarantees data delivery and guarantees no data loss. This is done with a write-ahead log. So there's 3 different repositories underneath NiFi. There's a provenance repository for the provenance they were looking at, flow file repository that has all the flow file information of what's moving back and forth, and then the content repository. So there's separate repositories that are being written on disk in a write-ahead log fashion. So it handles going forward very fast and designed to work together and allow consistency of data, guaranteed delivery of data, and no data loss. When you look about the prioritized queuing, oftentimes, again, not all data is created equal. There's some data that you want to react to and has more importance in your environment than other pieces of data. Out of the box, NiFi has 4 different prioritizers. Oldest first, newest, largest first, smallest first. You could do custom. There's also one that's a priority attribute prioritizer, which allows you to say that I'm going to look at this attribute on a flow file that maybe it is system classification, and you can look at the value of that and decide that for emergency systems, this piece of data has higher precedence. So what NiFi will do is when data is flowing through the queue, data that's using that will take precedence over other data in the queue. And if these don't meet your needs, you could build a custom prioritizer and use that instead. And this just visually shows where it would be. So on that connection, you could schedule, you could choose which prioritizer you're using. In this case, it's using the priority attribute. So again, that's something that you would pick an attribute from a flow file and say, this attribute takes precedence over everything else. And the value of this attribute has precedence over the rest of the data. NiFi, like I said, is designed for extension. So processors of ingesting data, egressing data, transforming data, making routing decisions are very easily extensible. There's a notion of controller services. You could think about those as like a connection pool, a JDBC connection pool, or other resource that you want to share between processors that are expensive to create. So it could be a WebSocket connection, it could be a JDBC connection, it could be something to a Hadoop system or Hive that you want to have a pool of resources. You'd have a controller service for that. And those are easy to extend. NiFi uses this notion of reporting tasks to send data to other systems. So I mentioned getting provenance data out of NiFi. There's a provenance reporting task that will take the provenance data that's being generated and allow you to send that to another system. You could also implement those very easily. Prioritizers, the user interface, and everything you see in the user interface and everything that you could do in the user interface with NiFi is all done via a REST API. So anything that could be done in the UI, you could do with a REST API as well. May not be as easy to work through that API and how to put it together, but everything is exposed via a REST API, so you could extend it and do things that you need to do. One of the things that's important to kind of think about with NiFi is often as humans, we want to put things into boxes that we know. And depending upon what your background is, the environment you work in, and what you're thinking about, people tend to group NiFi into one of these 4 boxes. Oftentimes, whether it's a processing framework, messaging bus, ETL, or enterprise service bus. So just go through these 4 different boxes and just give you some ideas of things to think about of how NiFi compares to those systems. When you think about processing frameworks, there was a talk in this room before about Flink. Oftentimes people start to think about NiFi and think, oh, this is like Flink or Spark or Storm or some processing engine like that. It's not. NiFi, so you look at those types of systems and they're designed to do very complex analysis, scale across thousands of nodes, join multiple streams of data, do windowed operations, and they work fantastic for those use cases. NiFi doesn't do that. You'd often see NiFi clusters in the tens, not in the thousands or the hundreds. If you think about joining multiple disparate streams of data, that's not something that NiFi does either. Right? So not designed for that. As far as the processing systems, you would use NiFi in front of it to massage the data, to manipulate the data, ingest the data, get it ready for a system like Flink or Spark to then do processing on. So you often see NiFi playing the ingestion role, making routing decisions as to where the data is going to go, doing transformations of the data in preparation, then delivering it somewhere where Flink or Spark or Storm or another processing system can pick it up and do a complex process with it. When you look about NiFi compared to message buses, you said that there's a connection between them, and you'll often hear that talked about as a queue. And immediately people start to think about, well, is that a JMS queue? Is that Kafka? Can I replace that queue with Kafka? What is that? Is NiFi really just Kafka or a message bus? And it's not. That term gets used. It really, you could think about it as an in-memory queue of just to move data between two objects in memory in the same JVM, and it's just doing that there. So it's in memory and backed on disk. But tools like Kafka and other products in that space, they're really designed to say, give me as much data as you can, as fast as you can, and I'll hold on to it. And then when you're ready, ask me for it back. As fast as you can read, I'll give you back the data. NiFi works from saying that I'm going to ingest this data, I want to make some decisions with it, I want to do some manipulation to it, and then deliver it somewhere. Okay, so you'd see Kafka, JMS, and so forth are really much just, give me this byte buffer that's just a blob of data, I'm going to hold it, and then ask me for it back. Okay, and NiFi isn't that tool. It usually uses these tools to deliver data to something else. And again, it really is this interactive command and control. So if you compare it to Kafka, you could think about your way that you produce data into Kafka and then get data out, it knows nothing about in the middle, it just holds it. NiFi is for what do you want to do in the middle. Okay, you want to take this piece of data that you're ingesting, you want to transform dates to be standard dates, you want to convert JSON to Avro, XML to CSV, whatever it may be, and then route it. So you think about NiFi. Those are things you wouldn't do with JMS or Kafka. When you think about ingestion frameworks, Spring, Camel, Flume, and so forth, those tools are all designed with a developer in mind. Right? If you're going to use something like Camel or Spring, you're writing code using that as a tool for you to provide an application. You're then on the hook for doing the UI around it, for making code changes, for everything that you want to do around that solution besides just an ingest of data. NiFi, the first audience, is the person in charge of understanding the flow of data in an organization. Right? So it's extensible, provides very rich support for developers, but that support is fantastic to extend things. The primary audience is this UI and someone that understands the flow. So you're visually modifying the flow of data and handling flow of data through an enterprise, whether that's from a cell phone, from a plane, from a car, all the way back to where it lands in, say, Hadoop or Cassandra or S3 for someone to do further analysis. It's that whole flow. Okay? Other tools are designed for you to build an application on top of. NiFi is not a library you could use inside of a product. When you compare it to ETL tools, and ETL continues to get fuzzier and fuzzier as to what constitutes ETL these days, there are oftentimes a lot of confusion with NiFi being an ETL tool, especially when I stand here and say you could transform data. People are like, well, you're talking about ingesting it, so it's extracting it from somewhere. You're saying transform it, and then you're saying I'm going to push it into HBase or Cassandra or somewhere else, so that's loading it somewhere. But it's not really one of those. NiFi is never going to be in the same space as an Informatica, or something like that that's truly designed for ETL. Those tools are often very designed towards getting data from a data warehouse, doing table-level manipulations of it, and delivering it to another warehouse or to a data mart. Very tied to schema, very tied to a database world. NiFi could understand schemas, can work with schemas, but is in no way forces you that. You often see people that may ingest data from a social media site and then also do image recognition in the same flow. So it is really up to you as to what data you want to ingest and how you want to work with it. There are things that kind of muddy the water of transformation, but you can think of it more of row-by-row transformations, not complete table transformations. Okay? You wouldn't use NiFi to say, I want to transpose a table from being columns to rows. But an ETL tool could do that all day long. Okay? And NiFi, you wouldn't use it for that role. So now if we look at Apache MiNiFi, the idea here was to say, let me get all the goodness from NiFi and move it as far out to the edge as possible. Whether that ends up being on a cell phone, on a cash register, in a car, somewhere. Let me move it as far to the edge, whatever that may be. For some people, the edge is, I just have servers in my data center, and that is my edge, and I want to collect log data from it. Okay? You don't need something like NiFi with a UI and everything else in that world. Right? So NiFi is born in the data center, assumes that it uses and can use all resources on the server that it's on, whether that's CPU, memory, network, disk. Whereas MiNiFi is designed to believe that it's a guest on an operating system. Okay, so it's a guest and will behave accordingly. Whether that's on a cell phone or in a server, it's going to run as an agent that's going to do some sort of ingestion, some sort of routing, intelligent decision making, and then delivering it somewhere. But when you look at the feature set, it's almost identical as the core features. You still have the same guaranteed delivery, you have data provenance, you have back pressure and buffering. The things that are different is when you think about something that's going to run on the edge where there isn't a UI, now the deployment becomes different. So in the case of MiNiFi, it's design and deploy, and this notion of warm deploys. In the case of NiFi, the UIs that I showed you, you literally could start dragging and dropping and changing that UI, changing the flow of data as data is moving. So if you're hooking up to a stream of data, so say a stream from Twitter, as that ends up being a common example of I want to ingest some stream, people have a hello world is now actually hello Twitter. of your ingesting this tweet, you could have a series of processors in a NiFi flow, stop one of them because you want to change a routing decision or change how you're transforming data. The rest of it's still flowing, and then start it again. Okay? Or change the destination. You no longer want it to go to Cassandra, you decide that you're going to have data go to S3. So you could stop it and change where data is flowing. In MiNiFi, that doesn't necessarily work. You're not going to have control, oftentimes, of these devices, whether it's just servers in your data center or things that are outside the walls of the data center. So there's this notion of you design it and deploy it, and then you could update it along the way, but it's not that same command and control. When you look at realities of outside the data center, there's oftentimes limited computing capability. These things become smaller and smaller. Limited power and network. Depending upon how far out you go and what devices there are, sometimes they don't have a full networking stack. Okay? So things become much more limited. There's no UI, they may not be physically accessible, and different things to contend with. So MiNiFi takes several precedents from NiFi. First, with site-to-site. So site-to-site is a protocol used from NiFi to NiFi nodes. You often see, and you can see references of it being used between NiFi and other systems. It's a Java client library. There's examples of using it to communicate between NiFi and Flink, NiFi and Spark, and different ways you could talk back and forth between NiFi and other systems. MiNiFi uses that same library and that same protocol of being able to now talk between MiNiFi and NiFi. So this guarantees data delivery. It handles load balancing between where you're talking. It's secure, and it's also extensible. When you look at data provenance, again, that same thing being adopted from NiFi to say, well, if we're all the way out at the edge, even if I'm collecting data from a cash register or from a server that's in a remote data center or from a machine in a warehouse, I want to understand everything done to that piece of data from the point that it was created and ingested all the way back. So you have data provenance in MiNiFi as well to capture the transformations and manipulations of data and send that along to NiFi. So now in an ideal world, from the point of ingestion all the way on the edge, all the way to when data lands in a data center and a data science is looking at it, you would have the journey it took, and you would have an understanding of everything done to that data all the way through its journey. And this again just shows provenance UI. And you see a similar thing. This was retrieved, there's attributes modified, content modified, and again, this shows the details of it. So you can see that there's a component here called listen HTTP. So you could build RESTful services with NiFi. There's listen HTTP responses. You could send HTTP, different protocols. So even though we're talking about this in an IoT setting, you can start to look at the pieces of MiNiFi and NiFi, embody a lot of the core concepts of reactive programming. Where things differ from MiNiFi is the world it runs in is quite different than NiFi. So it's a matter of trying to get the sizing right and get the fit right. Feedback loop is longer, right? It's design and deploy. But there's declarative configuration that you use after you design it. When you deploy it, that's done via YAML. The bundled components are reduced, so you have a smaller footprint. There are several flavors of MiNiFi. There's MiNiFi Java. So this is an easy and a great way to get started with it if you have an environment that you could run the JVM. So you could literally take almost every component and every processor in NiFi and have it run with MiNiFi Java. By default, it doesn't include all of them, so it has a smaller footprint, but you could easily add them. Then there's a MiNiFi C++. So this again, okay, now we're going to make it even smaller, so now it could run in more embedded environments, run a cache register, run in places that can't run a JVM. Here, though, the processors you can obviously move over, so there's a smaller footprint. There's currently less processors, but a lot of active work going on in the community to keep adding and adding to it, and some that are quite different than what you'd see in other places. And then you have the smallest, where now you have it being written for particular devices. There's work that's been underway for MiNiFi running on Android, MiNiFi running on iOS, MiNiFi running on different operating systems for phones, and to finding other target OSs and architectures to run it on. So you really end up thinking about it as like, it's like MiNiFi for ants. So it gets smaller and smaller as to where you want to run it, what you want to run it on, different language implementations for these different environments. So whether it's Java and it's easy and you could just have it running on a Raspberry Pi, which oftentimes is not really fair sometimes to call it a device because it keeps getting larger and larger, but all the way down to running on a phone, running on a router, running on a scanner, and running on things like that. So if you look across this, you see that you have this here of we want to have this edge all the way out there. You have these different sources of data that may be there. You may have this regional infrastructure, or maybe you're having data that stops along the way for some sort of processing as it's going. And then you have this core infrastructure where it goes to. So you want to have this content and these commands moving back and forth, and then data and events as well across the whole thing. So when you look at this, I think you'd often see where you have MiNiFi or NiFi all the way at the edge. Again, whether that edge really is an IoT or industrial IoT environment, or whether it's servers in a remote data center. And then NiFi on the other side where it would be more on a core location and someplace that you need that processing power and a UI for it. So you look across some places that you see MiNiFi working today. There's been a lot of work done on having it run in a connected car and working with car manufacturers to put MiNiFi in a car and running in a connected car. You can see here running on this network and how it would work. This just digs deeper into the architecture of how it's working in that connected car. So listening on the CAN bus, Ethernet, and so forth, collecting it, parsing the different data, making routing decisions, right? Making prioritization decisions, filtering out data. Oftentimes you'll see whether it's in a car, whether it's on an oil rig, whether it's in a different manufacturing setting, you have a lot of sensors that produce a lot of data. Many times, you're not interested in all the data all the time. So you often see MiNiFi used in these environments on the edge where you're going to collect some data, and maybe you just want to understand the flow of water through a sensor, and you're going to collect that data and send back water flow. And then all of a sudden, if you notice that the flow of water drops below a certain threshold, then you can use MiNiFi to turn around and say, well, great, now I want to actually take the data from these other 900 sensors, grab that, and now send that back because something's not right. Okay? So this ability to filter and prioritize, you often see MiNiFi used to make those types of intelligent decisions. Consume one data point, constantly send that back because you want to have that one data point going back, and then if a threshold is violated, so you need more data, of now having MiNiFi, as its data is flowing, make that decision to say, a threshold has been breached, I'm going to go collect the rest of the data and now send that as well. Okay, so you can make these intelligent decisions at the edge. With no code you're writing, no changes you have to make, you design what this flow should be, deploy it, and you can have it making these decisions on the edge. I don't have the video of this embedded in the slide, but if you search for it, there was this conference for the Geneva, and there's actually an example of people that use MiNiFi in a car, and they were opening and closing the sunroof based upon what the car perceived the temperatures were and modifying where it thought its GPS coordinates were. So it was either in a place that was sunny or a place that was raining, and then opening and closing the sunroof of the car. So you could use it to do all sorts of creative things. If you look around, you'll see examples of people and colleagues I've worked with at Hortonworks that have used MiNiFi to detect Bluetooth. And then a gentleman I work with of detecting a Bluetooth signal on MiNiFi and a Raspberry Pi, had it attached to his dog's collar and would know if a dog came in or out of the house, whether he could turn on or off a sprinkler system. Doing a similar thing to understand, Wi-Fi access points and understand, Wi-Fi signals from MAC addresses from phones to know if you recognize a phone, turn on or off the sprinkler system. So different things that you could do, and people could get pretty creative as to what you could do with this data and these systems on the edge. I've seen it as well and worked with customers that are in the retail space of using MiNiFi on cash registers and being able to make these decisions on cash registers, gather data, transform data, and move it across. and different places that you'll see MiNiFi in use today in IoT settings. So when you look about the ecosystem of this and where it goes, so today there's a framework to be able to extend this ingestion, right? So it's using site to site that's being pushed to all different languages to allow this communication. Reducing the footprint of NiFi, which now became MiNiFi, also makes this very palatable to move it closer to the edge on different things. But you end up with problems sometimes, right? You end up, once you start to deploy this in different environments, then the very next question becomes, that's fantastic that now I have thousands of MiNiFi agents running in my environment, but how do I control them? How do I control them? How do I manage them? How do I update them? All these types of questions start to pop up once you deploy it beyond a home toy. There's work going underway in the community to have this notion of command and control for MiNiFi. There's a link here of where that lives out in the Apache Wiki. For this architecture, you can see a discussion and a lot of work that's been underway, and you can see some of the code in GitHub as well of where this is going. So now, within tooling in NiFi, you'd be able to control and send commands to MiNiFi agents running in an environment. So now, if you do deploy these in a field situation, and say you work in a manufacturing setting and you have MiNiFi deployed in a manufacturing plants around the world, and you need to have hands-off control of them, then the idea is that you'd be able to use this command control infrastructure within NiFi to manage those MiNiFi agents, send updated flow information as to what they should do, software updates, send different commands to do different things, and control it from afar. So this is actively underway. So if you're interested in the space, I would watch that, join in and participate of how to actually help drive this so you could truly command and control them from afar. You'll see continuous pushing of being able to have this flow versioning of NARs, versioning of flows. NiFi has the notion of extensions, the extensions being processors. In NiFi world, those are called NARs. If you looked at them, they're purely just like a Java archive, stands for NiFi archive. It's a jar with a little bit more added to it. There's an idea that's being worked on, and again, document in the community, of how do you have that be a repository? Similar to something that you've seen where it's like Spark packages or Spark projects or Maven, where now you'd have these processors that are registered in an external repository that you could go and download within NiFi to be able to pull them down and use them, and discover them and use them. There's also a variable registry underway, and you'll see as you start to play with it of how that could help be able to dynamically change variables in NiFi and pull more and more information out so you can move it across environments. So if you think about, why use NiFi, why use MiNiFi in these environments, whether it's IoT or not IoT, it really comes down to a handful of reasons. Moving data is multifaceted, is hard. There's lots of challenges once you go beyond the simple use case of how do you move data. How do you get data from A to B, guarantee that it got there, handle the routing of it, transformation of it, handle networking problems, a variety of different things that come up. Provide common tooling, right? So NiFi and MiNiFi works more like a library in certain environments with like a cell phone, but NiFi specifically, and then MiNiFi in general as well, these are tools that are common that you could use to solve problems, oftentimes without having to write any code at all. And it comes down to that last bullet point, right, of empowering people that are in control of the data flow, not necessarily having to have someone that wants to change the data moves, then have to pick up the phone and say, look, I really need you to change this code to do X, Y, and Z. And then you end up in this long cycle of you're constantly supporting just changing code for operational situations, whereas NiFi and MiNiFi are designed to say, this is there, the person that's working that operational space of handling the flow now has a UI to use to control that flow of data. So if we look back over that IoT world reference and we lay this out, you can see at that level 1 at the edge, you see MiNiFi being embedded in devices. At that connectivity, MiNiFi and NiFi are data source agnostic. When we talked about flow files earlier, I said you think about them as an HTTP response. no different, right? Your browser doesn't know what content's coming back. It has plugins to handle the different content. But as far as HTTP goes, it's just a buffer of data. NiFi and MiNiFi, the same way. It's agnostic to what data is in there, but gives you the ability for you to understand what data is there and how to work with it. Secure and guaranteed. The bidirectional communication, I may have alluded to it, but not explicitly mentioned it. The site-to-site protocol and the connectivity between. With NiFi and MiNiFi, or NiFi to NiFi, you have bidirectional communication. So MiNiFi could be sending data from the edge. I mentioned of it making decisions of what's important to send. You could also send data from NiFi back. So you often see people wanting to explore and to put in place systems where MiNiFi is collecting data, sending it to NiFi. You're training a model offline in NiFi, pushing it to someplace else, perhaps Spark or Flink. A model gets trained. NiFi picks up the model that's updated and push that model to MiNiFi. And MiNiFi could execute and make predictions based on that model and decide how things flow. So you can have this back and forth communication. When you go further up to this edge computing, again, prioritization is there in both. Command and control is something that's well underway in the community. And then simple event processing. Again, something that you'd see that's different between MiNiFi, NiFi, and things like Spark, Storm, Flink, where they're very much designed for complex event processing. MiNiFi and NiFi more for that simple event processing. Data provenance, and then the rest of the stack you see as typical things that you find in an enterprise today, whether it's Hadoop or another system, applications, and then all the collaboration and processing on top. So here's some links to learn more about it or join the community, participate in it. I thank you for your time, and I'm more than happy to take questions. I just have one request. If you could just use the mic that's right here, that would be fantastic. Oh, right in front of you. Yep, sorry.
Will this slide be available?
It's currently available today.
Oh, okay.
So you go to nifi.apache.org, and you can download NiFi. So.
No, I mean the slides.
Oh, the slides? Yes, I'll make them available. Sorry, I thought you were asking about NiFi.
No.
Yep, I will certainly make the slides available.
And the other question is, you mentioned that the NiFi cluster can be like 10 nodes or something.
Mm-hmm.
I mean, what if I have terabyte and terabyte of data that I need to collect?
So that's fine. So you often see NiFi clusters that are in handfuls of nodes. NiFi is not designed as a permanent data store. So if it's ingesting terabytes of data, that's perfectly fine. It's designed for ingesting, doing some manipulation for it, and delivering it somewhere.
But my cluster can be as big as I want it? Because you mentioned something like 10.
You could have a larger cluster. In practice, you often don't see clusters, even for terabytes of data, that are that large because of how it's designed and what its role is.
I've installed NiFi, and I see that it creates lots of repositories and tons of files. How much, how should I tune it for how long? Is it just as much as disk space I have? Or?
Right, so NiFi does have repositories underneath it. So I think the question was, you see lots of repositories and files NiFi creates. How do you tune it? How do you scale it? So there's a provenance repository for all the provenance information, a flow file repository, and then a content repository. Each of those could be tuned for how much data you want to store, how short or long you want to store it for. In the case of even provenance, you could decide that you don't ever want to put it on disk. So you could have it all just be in memory. So you could tune it based upon how long you want to keep the data around on that node, how short you want to keep it. You often will always want to spread the data across different disks. So you would get the parallelization from an I/O standpoint. So you could spread it across. Mm-hmm. And then it comes down to what your business requirements are for how long you want to keep it. Again, NiFi is often not used and is never used as a data store. So this data is in transit to somewhere. Mm-hmm. So the thing that you'll see if you have the time, let's say it's only an hour that you're storing the content for, and you're working in the NiFi, and you're sending the data somewhere, if you walk away and come back and you want to go look at the content from a flow file, you're just going to get a message back that says it no longer exists. So it's really just figuring out what makes sense from a business case of how long you want it to hold the data.
I have two more questions. Should I ask, or if other people have questions?
The floor is yours. Go ahead.
Okay. And so Should I have one class, one say I have a TCP, listen TCP record processor. Should I have one processor per node, or what is the best configuration? Or can I have multiple processors per node?
Correct. So the question was, can you have more than one processor per node? Is that right? So the way that it would work is NiFi in a clustered environment. What you see on the graph, for all intents and purposes, is running on every node in the cluster. The same exact flow you see in the graph is running on every node in the cluster. There are certain data distribution patterns that change that slightly. Listen TCP, obviously you're going to have a persistent connection from somewhere. So what you'd want to do is you'd want to have, if you had multiple nodes in the cluster that were having a listen TCP processor, then you'd want to put a load balancer in front of NiFi.
I do.
Okay, so then you're going to have clients that are going to connect to different nodes. And they're going to have a connection start sending data. That's perfectly fine. So that's perfectly fine to do that and to load balance in front of it, have it go to different nodes, and then you do the rest of the processing. What you need to think about though is when you receive that data, and say in your case it's over TCP, and you're going to make some decisioning, think about that data is flowing on that node it connected to. NiFi doesn't shuffle data between nodes. Okay, so if you had 5 nodes and you had, say, 5 clients and everything worked out perfect in the load balancer, you'd have a connection per client to per node, and the data would stay on that NiFi node as it's flowing.
But if I have, okay, so it doesn't, so whenever I create a processor, it's just allocated to one of those nodes?
No, it doesn't allocate it. So when you create a processor on the graph, it is that same graph is being shared amongst, it's being replicated across all the nodes. So NiFi internally is communicating.
So only one copy per node then?
You're going to see that exact graph is running on every single node.
So it's one copy?
One copy per node, right? So it's running on every node. You could control the concurrency of how many, you can think about as threads, how many threads NiFi is using per processor. But what you see on there, you could think about it as you're modifying that flow no different than, say, Google Docs. If you and I are working on a document collaboratively, we're both seeing the same thing, 2 different browsers, NiFi the same thing. That flow you're manipulating is being synchronized, because that's just an XML representation of what the flow is, being synchronized between the nodes so they'll always look the same. You could go to the UI on every node, it'll look identical.
Yeah.
So they're doing the same exact flow on every node.
Okay.
Okay?
One last.
Okay. And then I'm around after if you want to.
Can I ask one last question? Or should I?
Why don't we give this gentleman a chance, then we could talk after.
Are there any other similar product like NiFi?
You said, are there other similar?
Yes, are there similar product like NiFi offering try to support IoT kind of initiative?
There's definitely in the IoT space, I'd say it's extremely fragmented right now. And I think the last I looked, there's like 400 vendors and probably a lot that offer some sort of frameworks. It's all a variation.
Yeah, so how do you evaluate NiFi's position in this industry? I mean, does it have any like a strong support from a big player in this industry?
So I think you'll see that there's, Hortonworks that's behind it. There's other customers that are behind it in IoT space. I think you'll find more support. I know there's work going on to try and work with hardware vendors in the IoT space and have MiNiFi certified and running on hardware that you could buy off the shelf in the IoT space. That doesn't exist today, but I think there's a lot of effort underway. And a lot of people that are using it throughout the community in different production settings with MiNiFi in an IoT space.
Okay, so what I'm wish to hear is some like for example, Tesla is trying to use this kind of thing. That'd be great. Kind of, that's what I'm.
Right. I don't know if Tesla is. I know from a Hortonworks standpoint, there's been a lot of work done with car manufacturers and doing the connected car. Nothing that I can publicly talk about, but there's a lot of work going on of having it run on connected cars.
Okay, thank you.
Mm-hmm. Thank you.